In this video, we discuss searching and sorting. Sorting is to arrange a collection of items into increasing or decreasing order. It is used to pre-process the collection to make searching faster. Before you search, you sort. Common sorting algorithms include bubble sort, selection sort, merge sort, quick sort, and radical sort. The bubble sort is the most inefficient approach. Let's see how it works. So first, in the first pass, search go from the first element to the last element and repeat swapping an element and the next element if the element is greater than the next element. And in the next part, you repeat again from the first element to the element next to the last element. So that's why the complexity is the order of n squared. The space complexity is a constant O1. Let's look at an example. Given an array, in the first pass, going from the first element to the last element and compare each element to the next element. So comparing 54 and 26, 54 is greater than 26. So here we switch the two elements. We switch the two elements. So now we have 26 in the first and 54 in the second position. Going further, now we are at the second element. 54 is less than 93, so we don't do anything. Moving to the next, 93 is now less than 17, so here we switch. Moving next, 93 now being compared to 77. 93 is greater than 77, so here we switch it again. We switch. So you can see that 93 is kept bubbling up again and again. Until it is swapped to the last element in the array. So with the first pass, we put 93, which is the maximum, to the last element in the array. We repeat this with the second pass. And in the second pass, we go from the first element to the element next to the last element and repeat again and again. This is the Python code. The array is named, or the array parameter is named a list. The outer loop from the last element back to the first element with the step of -1. So in this outer loop, you can see that we keep bubbling up the maximum to the last element, and then the element next to the last element, and again that way. And now looking at the inner loop, for each element from the first to the last or the next to the last, etc. If we see the element is greater than the last, the element just after it, then we switch the two elements. This actually can be shortened, writing something like a list I, and then a list at I plus 1 equals a list at I, this is I plus 1, and a list at I. This more compact. So then later we have some test code. Given a list which is an array, and we call the function keeping the array to the function, and then print the result. Citizen sort is simple but inefficient. This is how it works. The algorithm repeats finding the ith smallest element and move it to the front until all elements are sorted. And this follows ascending order. Correspondingly, we can also find the ith largest element and move it to the back. If instead the algorithms follows the descending order, then it can repeat finding the ith largest element and move it to the front, or correspondingly find the ith smallest element and move it to the back. The time complexity is O of n squared, and the space complexity is O1, which is a constant. Let's look at an example. Given an array, we look from the first to the last element, and we find that 93 is the largest element, then 93 is moved to the back. Now we loop again, but only loop until the element before 93. 77 is found the maximum, then it is moved to the back. We do this again and again until all the elements are sorted. In the code, the outer loop loops from the last element back to the first element with a step of -1. In each iteration, it looks for the maximum. And once the maximum is found, switch that with the current element. The test code here tests the array and print the sorted array after sorted by selection sort. What is quicksort? Quicksort is to pick a random element and partition the array such that all numbers less than the partitioning element come before the elements that are greater than it. The time complexity is O of n times log of n, and the space complexity is also O of n times log of n. Now let's see how partitioning works. Given an array, we select the first element, the element that is 54, which is the first element, and we select that as the pivot element. The second element is selected as the left mark, and the last element in the array is selected as the right mark. So we keep moving the left mark to the right as long as the element is still less than the pivot. And the left mark hasn't crossed the right mark. So when I get to 93, 93 is greater than 54. So right here we stop and check the right mark. Similarly, we move the right mark to the left as long as the right mark hasn't crossed the left mark. And the value of the element at the right mark is still greater than the pivot, which is 54. Right at the current right mark, we have 20. 20 is less than 54, so we stop. We have 93 and 20. We switch those. And we keep doing the same thing, moving the left mark to the right and the right mark to the left. At some point, we get to this status. Checking the left mark value, which is 77, greater than the pivot, which is 54. And the right mark element, which is 44. 44 is less than the pivot, which is 54. So here we exchange, we switch the two elements. And we get to this. Now we keep moving the left mark to the right and the right mark to the left until they cross each other. And finally, we switch the right mark and the pivot. So that we get to this status. 54 is now moved to the position of the right mark. On the left of 54, all the elements are less than 54, and on the right side of 54, all the elements are greater than 54. Now let's look at the code. The main function is quicksort, which takes an array, namely a list. And then we call to another function, namely quicksort helper. The first call takes 0, which is the first element, and length of a list minus 1, which is the last element in the list. So this function is recursively called quicksort helper. Take the list first and last. First the first element and last the last element. If first is less than last, we call a function namely partition. This function was illustrated in the previous slide to find out the split point. So from the previous slide, we saw that elements before the split points are less than the split point element, and elements after the split point are greater than this element at the split point. And then we call quicksort helper for the first half, and also we call quicksort helper for the second half. And this is the code for the function partition. So the pivot value is stated as the first element. The left mark is the second element, and the right mark is the last element. And then we have a loop. This is the outer loop, and in the outer loop we have two other loops. The first loop moves the left mark to the right. So as long as the left mark hasn't crossed the right mark and the element at the left mark is still less than the pivot, and we keep moving the left mark to the right. So if we get to the element that either greater than the pivot value or the left mark cross the right mark, then this loop stops. Then we get to the second loop. The second loop moves the right mark to the left, and it is kept moving to the left as long as the right mark hasn't crossed the left mark and the element at the right mark is still greater than the pivot value. So when we get to the element that is less than the pivot value, then the loop stops. If the right mark and the left mark haven't crossed each other, then we switch the left mark and the right mark, just like illustrated in the previous slide. And if eventually the right mark crosses the left mark, then we set done to true and we stop the outer loop. And finally switch the right mark and the first element. Then you turn the right mark.